Okay, it's about 2 minutes past. I'm going to get started. We'll end the polling. Share the results with everyone so you can see what your colleagues all answered. Thank you all for your for reporting back to us. First thing, good afternoon, good evening, good morning, depending on where you're at. This webinar is going to be recorded, and a link to the recording will be sent out after the webinar. It will also be available on the HighByte channel on YouTube, which I recommend you all go to and subscribe to, as we're continuing to put up a lot of great video content up there. So we are recording this, and I'm also going to turn off my video as I go through these slides. Let me close this. Okay, so I want to thank everyone for joining our webinar on scaling your industrial data to IT systems. I'm joined by Aron Semle, the Chief Technology Officer at HighByte, who will perform the demonstrations, which will take the majority of this webinar. I'm John Harrington. I lead the business development efforts for HighByte, and will walk you through a quick slide introduction to this topic of scaling your industrial data. I'm joined also by Tori Penrock-Cambra, who leads our marketing team and has joined us to monitor the Q&A. If you have any questions, please add them to the Q&A panel, and at the end of the session, we'll get to all those questions. If there are too many questions, we'll certainly get back to you via email, so don't be bashful. So for those of you who are not familiar with HighByte, HighByte is a software company focused on providing manufacturing companies with solutions to streamline and manage their data infrastructure as they strive to achieve industrial transformation. Our team has spent many years in the industrial software industry. Most recently, many of us worked together at Kepware and PTC. I want to start out by breaking down what we're going to talk about today: scaling your industrial data to IT systems. Specifically, what is industrial data? Many people think of PLCs, machine controllers, or DCS systems as their industrial data. These are definitely important sources of data and present significant challenges, but they're not the only industrial data. There are many other systems that have industrial data, including smart sensors, industrial gateways, MES systems, historians, asset management systems, HMIs, and all of this data is critical to your projects. When we think about integrating systems, and specifically industrial data, there are a number of challenges companies typically experience. In fact, many of you talked about these challenges earlier in the poll question. So the sheer volume of data points, which has increased dramatically over the last few years due to higher performant PLCs, inexpensive sensors, and many more production functions being controlled through automation. The age of machinery and the variety of vendors of automation equipment also results in many different device protocols, which each have their own unique data structures. These data structures must be combined from multiple disparate sources, each of which have different update frequencies and triggering mechanisms. In addition to the challenges with source data, we're now sending data to IT systems, which are outside the OT domain and are not designed for OT data, nor are they administrated by the OT team. Cloud data lakes seem to be taking the industry by storm as a way to store the data for visualization and analytics, and we're going to show you how to connect the two of them. Azure and AWS are certainly the leaders here. We also see analytics platforms, IoT platforms, many different legacy systems like your ERP, quality management, CMMS, and many more. And then there are all those bespoke platforms that you have throughout your company, applications, dashboards, databases. All of these need access to industrial data. When we look at integrating the industrial data into these IT systems, we must think of solution requirements to operate at scale. Connectivity is about leveraging open standards to move information, and fortunately, these are being widely adopted across the industry. But it's not just about connectivity. We also must standardize our data through the use of models, then normalize the data to meet those standards. Data must be aligned, assembling it into information models from multiple sources, correlated to a use case, pulling real-time master data, transactional data, and even contextual data all together into a single information object. And finally, our system must be agile. We must strive for reuse. We have to manage at an abstracted information model level. We're no longer able to manage at individual data points as there are just too many. And be ready to change, which could come from anything from the sensor all the way up to the application's data requirements. In fact, change will come, and you must be ready. So we've developed the HighByte Intelligence Hub to streamline your data architecture and ultimately scale your industrial data to IT systems. This combines connections with models to standardize and align the information. The Intelligence Hub was designed to be deployed and maintained by the OT team, accelerating systems integration and providing a platform to manage your industrial data infrastructure. I'm now going to turn this over to Aron, who's going to go through how these concepts are put into practice with the HighByte Intelligence Hub. First, I'll stop my sharing, and then I will launch a second poll question.
Awesome. While you're doing that, John, can you enable sharing?
Yes.
For me, perfect. It's cool. I'm looking at the participant list, and there's a number of names, people I know, which is cool, and then a number I've communicated with over email. So thanks for joining us. Hopefully I can show you something that I'll show you HighByte, but hopefully also get you thinking about data modeling in general.
Aron, can you share now?
Yep. Just
Great.
Give me a second. Let me know when you can see it.
We can see it. Why don't I end the poll and then you can take it over.
Awesome.
So just to give you, let me share the results. So Microsoft Azure by 50%, AWS at 16%, and then we've got some others. And then of course we've got 19% that don't plan on using cloud. So pretty much in line with what we probably expected.
Yeah, it's fun. I'll show you both. I won't show Google, but I'll show some AWS stuff as well as some Azure stuff. But so what I want to show you first is I want to show you what it's like when you don't model data. All right, so I've been around long enough. I was kind of part of the group that first figured out how we wire industrial data tags into the cloud. And I can look back and humbly say we did it wrong. And I'll show you why. So I'll show what it's like when you don't model, and then I'll show you what it's like when you do model. And then I'll show you once you have the model, what you can do with it. So that'll be kind of the flow. But to show you what it's like when you don't model, I have an OPC server that I have over here, and I've configured it to send data up to Azure. And I'm just going to enable that quick. And that's going. And if you're not familiar with Azure, this is the Azure kind of development console. And it's a pretty simple workflow. So I'm going to send the data up through MQTT to what they call in Azure an IoT hub. It's just like a mass ingestion point. And then from there, I've got a stream analytics job that's going to process that. And to show you what the data looks like real quick, it looks like this. So this is kind of how we have done it in industry, right? Where you have this JSON payload. I'll just jump into the viewer to make it look a little better, but we have a timestamp and then we have a series of values. And if you dig into what these values are, they're literally the OPC tag names. This is about as easy as you could get, right? Channel, device, tag name, with a value, a quality, and a timestamp. And we ship this up and we send it up to the cloud. So that goes into IoT Hub and it gets processed in this thing they call Stream Analytics handler. So it's taking the data, and I'll just show you the query that runs on this OPC data to make it useful. That's down here. And what I'm doing is I'm saying, okay, give me each one of those values in that array and then break it out with ID, value, quality, and timestamp, the attributes. And then I'm doing a little bit of massaging to give it a better date time to work in Power BI. So I'm saying, give me everything from IoT Hub, put it in this format, and send it out to Power BI. And then when I jump into Power BI, I'm here. If you look all the way to the right, you'll see my data model. No, I would argue it's not a model, but no big surprise there, right? Timestamp, the ID, quality, and value. And these, all my tags look like this. So, all right, let's try to use it. I want to create a really simple line chart, right? So I'm going to grab my value. I'm going to grab the timestamp on the x-axis. And whoa, that looks a little funky. What's going on there? Well, Power BI is trying to average the value of all the tags coming into the system. So we need to add a little bit more filtering. So I'm going to do this. I'm going to drag in the ID, and you can see I have 3 tags available. I'm going to select one of those. And okay, that looks a little better, right? I'm piping in a sine wave, I believe. And if I hit refresh, you'll slowly kind of see that start to, there it is. Let's say I want to add another tag to that chart. Well, okay, I think I just do this, right? Nope, doesn't work, right? It's trying to average the values again. So like, this is just the tip of the iceberg, right? Like, I literally can't add 2 lines to a chart in Power BI because my data has no model to it. And if I went even farther and tried to show you, well, if I want to put a gauge of the current value, we'd be here for 15 minutes and I would have to Google how to do this, and it wouldn't, I don't even know if it's possible, right? And then what's even worse, the worst part about it is once I've designed this page for one asset, say I have another asset that comes in on channel 2 current temp, there is no way for me to easily create like a page level filter. I might be able to do it if the names are somewhat consistent, but to filter between assets, so I want to see data for asset 1 versus 2, that becomes extremely difficult, right? So this is just the tip of the iceberg in terms of, if you push data into the cloud unstructured, you can't put 2 lines on a chart, right? So you imagine if you want to do machine learning or analytics or some advanced storage, it's going to be even harder. So when people hit this, right, what they do is they first run back to Stream Analytics and they say, okay, can I do some massaging to this data using the tag names to try to format this a little better? The answer is not really. Stream Analytics is powerful, but not powerful enough. So what you end up doing is, instead of going direct to Power BI, you're going to dump it to a database like Cosmos DB. You're going to have to spin up a whole new resource, which I don't have here, which is Azure Functions written in C# or Node.js. You have to pull it out of that database, try to format it with the tag names, and dump it back to a database, and then go to Power BI. If that sounds complicated, it's because it is. And you're going to waste a lot of engineering time and development hours, not only initially creating that, but then trying to maintain it and scale it across factories. Okay, let me get off the soapbox. Let me show you a better way to get data to the cloud, in this case, Azure. So this is the HighByte Intelligence Hub. We have connections, right? Inputs and outputs, and I'm not going to go through configuring the connections. It's pretty trivial, but you'll see we have an OPC connection. We've got some Azure stuff, and you'll see us add to this. I'll leverage the connections, but not show you how to use them in this. What's key to what we have is modeling, right? So in here, I've created an injection molding machine model. Now, what this says is, this is the structure of the data for every injection molding machine I have in my plant, across my enterprise, etc. So you can see I can jump in here. I can move attributes around. I can change data types. I can add a new attribute. You know, pretty easy. I can create models within models, do some advanced stuff too, but we're going to keep it simple. And we're going to say, here's my model. For my unified namespace, this is what a machine, injection molding machine, should look like. And then I'm going to jump into instances. So instances are the actual assets on the factory floor, right? And I've created 2. And you'll see this is where we map tag data or factory data to the model. And this is where tags die and stop, right? Tags don't go any farther than this. The cloud doesn't want value, quality, timestamp. It doesn't want to deal with tags. It wants to deal with structured data. So you'll see in here, I've got my cycle time. I've got that linked to an OPC server. And if I extend here, we got some cool browsers, so you can grab tags from the OPC server, drag them over. I'm also mixing data from SQL. We just added this feature, so if I grab my SQL connection, I can see my tables available, expand that one, excuse me, and I can see the attributes, the columns on that table. I can just drag that in. Pretty cool. And then I have some REST connectors, so I'm grabbing like the ambient temperature out here in Portland, Maine, where we are. So I package all that up, and that's my instance of the model. And you can see if we jump back, I've got 2 of those. And the last part are flows, right? So I've got a flow that leverages my connections and says every second, I'm going to grab injection molding machine 1 and I'm going to throw it out to Azure. And I'm going to do that for here too. And if I jump now to look at what that looks like in Azure, sigh of relief. This is beautiful, right? If I go all the way to the right, what you're going to see is the data model verbatim of what it is in HighByte. So I'm just so you see, I'm going to go back. There's that data model, cycle time, max, min temp. In Power BI now, I'm dealing with the same data model, right? Ambient temperature, current temp, cycle time, max, min, etc. Now watch this. I've pre-built this dashboard, right? But let's say we want to build the same thing. We want to chart the temperature. All right, so I'm going to grab current temp. I'm going to grab max and min temp. I'm going to grab, notice these aren't tags, right? This is pretty easy to read. And then I'm going to put timestamp on the x-axis, and boom, we're done. It was that easy, right? And so I built this in a minute. I can build this dashboard because my data is structured, right? And once again, step back. If it's this easy to build a dashboard with structured data, how much easier does that make analytics, machine learning, AI, any kind of advanced storage? It makes it trivial. And then what's really cool too is if I go to the reading view of this, let's not save those changes. I've created the dashboard for one injection molding machine, right? But over here, I get this picker and I can turn it on for injection molding machine 2. I did nothing for this, right? It just follows the same data model. So bam, I'm looking at injection molding machine 2. I could go into HighByte and define injection molding machine 3, run it through that same flow, and it would, without any work at all, Zoom's getting in the way, it would show up here. And I don't have it enabled, so you don't see any data, but it would instantly show up in the list and I can filter on it. Okay, so that is the power of structured data in the cloud, in this case in Azure. Now I want to show you, once you have the model defined, once you say this is my model in my unified namespace, what else can you do with it? So I'm going to turn, we could leave them all on, but I'll just turn them off. I'm going to turn on SQL. So I'm going to take the same data and I'm going to log it to a SQL database that's local on my machine. And I'll pull up SQL Explorer. In this case, I'm pushing it to this table. So let me just do a select quick. And you'll see the data in the same model is coming in, right? And being dumped to the SQL database. So if I wanted to use Tableau, I wanted to use any other application that uses SQL, it could leverage the same data model that everything else is using. And all I did is point it to a SQL connection. I did no extra work on modeling or putting together my data. All right, it gets even better. I'll show you a REST connector. So this is going to take the same data model and it's going to dump it out via REST post. So this is just this is a tool to collect the REST calls. And what you'll see is they're coming in on the left. And if I turn this on, or I click this one, you can see this is the payload. This is the HighByte data model being sent out to REST. This could be Maximo, Infor, SAP, whatever system accepts REST inputs, which is a lot these days. Same data. I'm going to show you these next two. These aren't in the official HighByte release, right? So this is just me hacking. This will probably be in a future release. We're getting some feedback on it, but I just really want to leverage and show you the power of this modeling concept. So I'm going to send the data to Influx DB, and I've got that on my other screen. Let me just pull it over. Influx DB is a time series database. Although it's a time series database, it does work with models. So this is a hosted version of Influx DB with Grafana on top. And I'm cheating. I just want to give you like the dry run. So it's populating it anyway, but Influx DB has the concept of buckets, right? So I'm pushing to a HighByte bucket. You can see in that bucket is my injection molding machine model. I didn't go and create this, right? This was auto-created for me from HighByte. I have all the attributes of the model there. I can grab the current temperature. I have the instance, injection molding machine 2. I hit submit, and boom, the data's coming in. I can do stuff like create a gauge, right? You can look at, well, this is pretty bad. You can look at the ambient temperature in Portland, Maine today in Fahrenheit, just above freezing, right? It's pretty cold up here in the Northeast, but pretty cool. All right, let me show you the last one. The last one is AWS Sitewise. So I'm going to push the same data model up to AWS that I did to Azure. And if you're not familiar with Sitewise, this is what it looks like. It has a concept of models and assets. So if you go into models, this is pretty interesting, right? When the big cloud platform guys are creating models and assets to ingest data into their platforms, they're going and doing some of this themselves. It tells you there's a need, right? For sure. We would make the argument, use an independent tool to do it, but to create the models. But essentially, I'm taking the HighByte model. I just pointed it at AWS, and I've put that, you can see injection molding machine inside the AWS models. If you go into assets, which is their version of instances, I've auto-populated injection molding machine number 2. And if you go into measurements, you're going to see I've auto-created all the attributes from HighByte. And here's the values. Now this part gets maybe creepy, cool, but weird, right? So AWS has the concept of a portal, which competes directly with Power BI. And I've gone in minutes using the data model because this assets are available, injection molding machine 2, I've created a dashboard in the portal that shows the real-time data from that asset coming from HighByte, right? And you can see this data coming in. I said it's not creepy, but what's cool is, to me, this is like the aha moment. If Zoom would get out of the way. 1 second. Oh, hold on. Basically, I'm going to show you that the Power BI view is the same thing as the AWS view. Look at that. It's the same. Why? Because it's using the same data model, right? Like that's the power. And it literally took me minutes. If we were streaming tag data like we do traditionally from OPC land or the industrial space into the cloud, this webinar would take hours, right? But once we just set up the connections, point and click, and the data model is the same across all these platforms. So hopefully that starts to sell to you the concept and the power of modeling your data. And with that, I think we're looking good on time, so we'll open it up to some questions, or I'll hand it back to John.
That was awesome, Aaron. I'm going to launch one last poll. Try and get some information, do a little bit of research from all the people that are on this webinar, but we'd love to hear what kind of databases you have so that we can develop technology for them. So as we're doing that, Aaron, if you can unshare, and I will share my screen. We'll jump back to one final slide, and then we'll jump into Q&A. All right, let's end the poll, and I'll share the results with everyone so you can see as well, because we're sharing this information. So awesome results. Microsoft SQL, exactly where we expected. MySQL, number 2. Postgres, great feedback. Thank you all for taking those, taking the polls. All right, let's close out. So thank you, Aaron. From the HighByte team, I'd just like to thank everyone for attending the webinar. Aaron, hopefully everyone thinks he showed an awesome and compelling demo. Obviously, we wanted to do this in a short period of time, so he went really quick, but I think he got the point across that models are critical. Models being produced on-premise by the OT team is really where it's at, but that we can feed the data up into these cloud platforms as well as any other platform that you have, and you can just make use of the data immediately, right? That's what it's all about, is scalability. So if you're interested in testing out our software, please go to our website or email us. If you'd like to have a virtual meeting, you can do that as well. You can email sales, or you can reach out to Aaron or I directly. And of course, if you've got a pilot project, we just want to get started. Let's get the software in your hands and get you going with it. So at this point, I'll turn the session over to Tori, and I think she was going to monitor our Q&A session and see what we've got going there.
Yeah, you guys hear me okay?
Yep.
Great. There's a couple questions that have come in. Can you guys talk a little bit about Spark B and how does HighByte Conforma work with Spark B?
Sure. Why don't I take a stab, and then Aron, you can follow up with any more technical information. So we do support Spark B. We're able to consume data over Spark B. So if you've got sensors or other applications that have Spark B, which of course is over MQTT. For those of you who don't know, Spark B is a sub specification that was written on top of MQTT specifically for the IoT industry and industrial data. And of course, if you go to the Spark B website, you'll probably see a much more elegant description, but essentially it allows us to work with industrial data much easier than straight up MQTT, because they put a number of parameters around it and they handle things like state management and stuff like that. So we started supporting Spark B back in October with our release, and we're able to both ingest Spark B as well as push out Spark B. So for instance, if you're using an OSI Pi historian, we could push Spark B data into that. At the same time, if you've got a sensor or you're using Ignition, we could consume Spark B data from those applications. So we can, as we talk about the HighByte Intelligence Hub, we can go either way with that.
Great. Aron, do you have anything to add, or would you like me to jump to the next question?
Nope. Yeah, let's jump to the next.
So here's a question for you specifically, Aron. Can you touch on real quick how HighByte normalizes timestamps for event triggers and how this could provide value for machine learning initiatives?
Yeah, I think so. I think I know that came through Walker. I think.
Yeah.
Which is to a cloud environment is a really confusing concept, right? From their perspective, everything's much more transactional. So I want to look at this machine at a point in time, one point in time, right? And I want to see all the attributes for the machine. And if you can get the data in that model, which we do with HighByte, it makes it much easier to process that machine state and run machine learning on it. Because if you're trying to deal with all these different values that are changing at different points in time, I mean, that's not going to run through any kind of machine learning that I'm aware of. It's going to get really difficult unless you're working with a single data point, which defeats the purpose of a lot of the value of like causation between data points and machine learning. So you want, this is the state of the asset at a point in time, and maybe those are 10 milliseconds apart, but it makes life much easier.
Great. This is kind of both a sort of a business use case and a technical question. Can you kind of explain the value of, you can model in the cloud, but what's the value of modeling at the edge versus the cloud?
Yeah, I saw the question. It's a really good one. It's an insightful one. The cloud is always modeled. I would say that, right? So if we're going to integrate two cloud systems in a friendly way, we have to model the data going in, which we traditionally haven't done. I think what's really interesting about that question is I think the future is modeled data in the factory too. I mean, I always say that the factory is like 5 to 10 years behind where IT is, right? So if you're going to assume that there's going to be more IT-like systems, which there are now in the factory with REST interfaces and transactional interfaces, you're going to be able to leverage that model in the factory environment more and more. So I think, pushing that model as far down to the edge, maybe it doesn't exist yet between the PLC and the HMI, but everything else should be modeled contextualized data. So push it down as far as you can. I think we will adopt modeling, whether we like it or not. It's just the future. Yeah.
The other thing I would add to that is modeling data in the cloud requires that you consume the data, you store the data, you then process the data, and then store the modeled data. And a lot of people have found that ends up, there's a cost to that. And there are challenges of doing that. So there's cost savings by pulling it down, putting it close to the machinery. The other thing that we've attempted to do is put together a system that the OT team can use to do the modeling. So typically when you're working in the cloud and you're working in Azure or you're working in AWS, it's less of an application and typically more of a development environment. We've focused on developing a solution for the OT team so that they can consume that data, rapidly put it into models, and then send it out. And like Aron said, it can go to the cloud, it can go to an on-prem application, it can go to an edge-based analytic.
Great. I'm going to just do a bit of housekeeping before I jump to the next question. So it's 1:32 Eastern time. If anyone, of course, needs to drop off, please do so. If you want to stay on and continue to participate in Q&A, let's do it. We're happy to stay on and do that. But if you need to drop or just want to handle this offline, that's fine too. Just send us an email at sales@highbyte.com and we'll get back to you right away. Okay, so you guys okay to take another question?
Yeah, go ahead.
Good. Okay. What about migrating? So someone asked, can we migrate our existing OPC UA information models to HighByte? And how deep can we model? As in how many levels, or like at HighByte, what we call nested models, for example?
Yeah, John, I can take that one if you want. So to date, we don't support ingesting models over OPC UA, but we're aware of it, and it's something we'll add in the future. I think we ingest now from SQL and REST, so the concept of ingesting complex data through our inputs we have, right? So it's just mapping that over to OPC UA, which probably is not a heavy lift. So that is on the roadmap. The question of how many levels, there's nothing in the code today to limit the amount of recursion, the amount of levels you have in a model. That said, at some point there probably will be, but I wouldn't think it'd be in the realm of like practical, something you'd hit. Interestingly enough, when it comes to modeling, especially people that are first starting, it's really good to start with like basic models. I think folks that start with like really complex, like 10 levels deep models, I don't know if don't try to model the unit. My opinion would be don't try to model the universe, right? Start with something practical that works. And then what's cool with HighByte is you can easily add and expand to it over time, right? We make that really flexible because we understand that models are going to change. But yeah, no limits right now.
Yeah, don't turn it into an academic exercise. Keep it practical.
Okay, I have a question about tech stack now. What about OPC like Kepware to HighByte to SparkPlug-B? Does that work?
Yeah,
for sure.
Yeah. So HighByte's got a partnership with Kepware, and Kepware is a great source for OPC data for us. So we can consume that data, we can bring it in, run it through our models. We can combine it with any other sources, remodel it. So you may be taking a couple of tags from a PLC, a couple others from a machine controller, a couple others from a smart sensor, all coming through Kepware. We can put all those into a single model and then send it out over Sparkplug. Not a problem.
Great. Okay, question about data storage. HighByte does not store data, correct? It's just a layer in between, like a service bus. Can we talk a little bit about what we do now and maybe give a hint to what we plan to do in the future as well?
Yeah, good insight. That's somewhat technical, insightful question. Yeah, we don't. So we'll do some caching depending on the input type that will cache data. We're looking at doing more caching for stuff like SQL to optimize communication out to like a SQL database or a REST interface on like a SAP or Infor server. So we're not hammering that. So those, some caching we have. In terms of data being a data store, we never want to be a data store, but there is an open question of if we should store data for a period of time through some of our interfaces to allow people to come back and make queries over like the last 5 minutes. So that might be a future feature we're thinking about. Trying to think if that so we do some caching on inputs, maybe some storage in the future, and then we also added just store and forward to our outputs. That's coming in the next release, so we can be reliable if communication to the endpoint goes down.
Great. John, you want to add anything to that?
No, I think he covered it. The store and forward that we're adding is going to allow you to turn it on by connection, and it is going to store to disk. So if there are problems on the computer that we're on, we'll store it to disk and comes back up, and we'll push out all the data that we had collected. So all good there.
Great. I have a question as well. This is a comparison question. So how would you compare HighByte with the Thingworx thing model concepts? And I might even just add on to that to say non-specifically, what's the difference between a product like HighByte Intelligence Hub and modeling things in an IoT platform in general?
Yeah, great question. So to peel the first one off, the difference between HighByte and like Thingworx modeling, really similar in concept, right? And actually, Thingworx it was really cool to see it, years ago. Now, kind of adopt this modeling concept and see it coming. But Thingworx is a lot more than just a modeling tool, right? The ability to build dashboards, do some ML, and some other things. You won't see us go most likely in that direction. We're going to focus really on that modeling engine, ingest and outgest, and all the pieces that we need to be able to transform this model data to other applications. So modeling is probably where the comparison starts and stops between us and Thingworx. And the second part of that question, Tori, can you remind me?
I think just to add to that, Aaron, we see modeling in a number of applications. In fact, SiteWise, we just showed you, also has modeling. And the challenge that companies are going to have moving forward is, you could model in 5 different applications, but what we're doing is allowing you one application to model in, and then what we're really focused on is pushing the data out. Right, so you model it in HighByte, you push it out, it'll land in Thingworx pre-modeled. They'll be able to ingest it and start using it much easier than if they were ingesting raw data. Similarly, SiteWise, similarly, all these other applications, Power BI, you name it. So the idea is to abstract modeling out of every application. In fact, we've had modeling in historians and in SCADA systems for many, many years. That's really a SCADA screen as a way of modeling data. The point is, if you have to model it 5 different times in 5 different systems, some of those are maintained by IT, some by OT, it becomes very hard. What happens when a change is made? So if you now have a single system that models the data in one place and then sends it out, then when changes happen on the factory floor, when changes happen in applications, you come into the HighByte Intelligence Hub, you make those changes, and then you push them all out. And you're able to have that one management location to make sure that your models are up to date, your flows are up to date, and the information landing in the different applications is designed exactly for them.
Great. Another question, can you talk a little bit about how you would install HighByte Intelligence Hub? How much, what's required for to deploy an instance? Could it run alongside other applications like an OPC server, SCADA system, or is it better to run in a separate instance? Sort of, logistically, what's required here?
Sure. No, I can answer that. It's pretty lightweight, right? So putting it on the same VM as an OPC server running, that's fine. I wouldn't have a ton of concern there. Or running it standalone. It hosts a web server, so it has the front end, and then it has a back end runtime. But John, I might mess this up, but early on we got it running on a Raspberry Pi with how many thousands of data points coming through?
10,000 data points a second.
Right. So, I mean, that's a pretty small piece of hardware, and it was running pretty quick. But if you do want to provision it on its own system, you can, right? It connects over OPC UA, so it's flexible in that way. And then we also have it running on Docker containers, exploring Azure Edge, Greengrass, and some other environments to run it on closer to the edge as part of these other systems to make it even easier.
Great. Question about cloud question here. So Azure has launched zones and AWS has Outpost, which brings processing closer to the source. Does HighByte see any advantage at running HighByte application on either? If so, what would that advantage be?
Yeah, I think I was actually starting to Google that. I saw that question come in. I'm not as familiar with AWS Outpost. I'm gonna have to do some research there. But I will say that I do see an advantage of running HighByte closer to the edge. So we kind of see 2 deployment models where you might have like a single OPC server in a factory, and HighByte might be installed centrally to take that OPC data and other data and turn it into models. But there's an alternative approach where you might deploy, and this is in our pricing too, John, if you wanted to cover cover that, but where you would deploy HighByte instances closer to the machine, right? Where you would do the transformation there. And it's all about trying to push that modeling as close to the actual asset as you can, because it just makes life easier when the data is modeled coming out. So I think, although I'm not familiar with Outpost or zones, really, I would say that, like I said before, we're looking at Azure Edge, running in Dockerized containers, running in Greengrass as part of their platforms to deploy something like HighByte at scale. So you could have, 20, 30, 40, 100 deployments in a factory and be able to manage that centrally.
Yeah, so to build off of what Aaron said, we have contemplated that in our packaging. So the way that we package the product is that you've got a single running intelligence hub, but some people may want to run lots of them within a single factory, and some people may only want to run a single intelligence hub in the factory on a big beefy server. So the idea is that you could buy them independently or individually for a factory, but we also have a site license, and all of our pricing is available on our website. So if anyone's interested, they can go check it out. But the idea is just, if you're running multiple hubs within a factory, once you get up to a handful of them, then all of a sudden, get a site license and you're good for a while, for as many as you want. So that's how we're handling the people that want to run at the edge, because we think over time a lot more people will be running at the edge.
This is a resource question. John, do we have like a white paper that we could share on the topic of data ops that goes into this a little deeper? So
we definitely have a white paper on data ops on our website. We've got a lot of different resources on our website. We've got a couple of different articles that have been written about HighByte or by the HighByte team. That white paper, we've got a bunch of different blog posts. So if anyone's looking for more information, we certainly would push you to our website, and there's a lot of stuff on there. And if you still have questions, reach out. And if we're not answering your questions in the white papers that we've got, then that's also great, because then that just gives us new white papers to write, Tori, right?
Yeah, that's
We're
right.
always looking for what's the next white paper that we need to put together for the industry, for our customer base. So let us know.
Great. Okay. I think that's a good wrap up. I think we got to a lot of the questions in here. So just a reminder, we will share a recording with everyone 24 hours after this event. Give us a day to get it out. We'll probably, we can put in there a link to the white paper too, just to make it easy on anyone who hasn't read that yet. And again, if we didn't get to your question or you want to send us one offline, sales@highbyte.com.
Thank you very much.
Thanks
everyone for coming. We'll talk to you later.
Cheers.
Cheers. Bye.